Hello, you absolute legends. We're going to explain the valence bonding of O2 diatomic oxygen. We start with the Lewis dot structure to see how many electrons are involved in bonds. There are 4 electrons involved in bonds. These are covalent bonds. So one of these bonds is a sigma bond, and one of these bonds is pi bond. One of them has to be a sigma because a sigma bond is what is formed first, and a pi bond is what is formed second. I'm just going to arbitrarily label one pair of electrons as a sigma bond, and I'm going to arbitrarily label the other pair as a pi bond. But we can do that without drawing any orbitals right here. Now, to get the valence bond, or to understand what orbitals are contributing to the sigma bond, and to understand what orbitals are contributing to the pi bond, we look at oxygen atom and what orbitals are being used by the valence electrons. Oxygen has 6 valence electrons in the second level. 2 of them are in an s orbital, and 4 of them are in p orbitals. Now, the s orbitals are full, so the s orbitals are not going to contribute to the bonding of the sigma or the pi because the s orbital is full. The orbital can only hold 2 electrons. It's already full. Now, the p orbitals, there is vacancies in the p orbitals. Specifically, there are 2 vacancies for every 1 oxygen atom. And all 3 p orbitals are going to be used right here. So we're not going to draw the s orbital to try to make this a little simpler. We're only going to draw the p orbitals. Okay? So this oxygen atom here has a p orbital that extends left and right, the x. It has a y orbital, a py, that goes up and down on the y-axis. And it has a z orbital that is going in and out of the board. I'm going to draw that one in red. And it's trying to go in and out of the board right here. We have 4 electrons. And again, I'm just not drawing the s orbital because it's full. It's not going to contribute to bonding, so I'm just not going to draw it. These 4 electrons in this these 4 electrons are spread out among these 3 orbitals that are going to be used for bonding. Now, this is 1 oxygen atom here, okay? So we have 1 electron here. We got 1 electron in this vertical orbital here. And this pz orbital, I'm going to say this orbital here is filled, but I'm going to put the 2 electrons, a little color coding right there, okay? So this is we have 4 electrons in our p set. The z orbital is filled. The x orbital has a vacancy, and the y orbital has a vacancy. And this is 1 of the oxygen atoms. The second oxygen atom is identical in that it is an oxygen atom. It has a filled s orbital. Its p orbitals, it has 3 p orbitals and also 4 electrons. In this atom right here, we have to draw an overlap between these p orbitals for a sigma bond, because when there is a bond, there is an overlap. And I'm again going to sneak in the z orbital coming in and out of the board in red here. Now, this oxygen atom, the second one, also has 4 electrons in its shell right here. It has 1 electron is going to form a sigma bond. Another electron is going to form a pi bond. And the 2 remaining electrons are going to be filled in the pz orbital going above and out of the board right here. Okay? So in this picture here, all I have are the p orbitals drawn. And I'm showing a good bit of overlap with this sigma bond. And remember, this is a sigma bond because the electrons in the orbital overlap is along the internuclear axis, this imaginary line that's the shortest path connecting the 2 nuclei. The pi bond is a current of electrons that flows above and below the internuclear axis. Now, these electrons, when I say flow, remember this p orbital is going up and down, and we're imagining like a flow, an exchange in between, where that p orbital is having, I'm going to draw some green lines to represent that p orbital. And that is the pi orbital right there. So that is a way to describe the sigma and pi bonds using valence bond for O2. Thank you so much.